buddy.
No.
Too bad. So,
My computer's not loading.
here we go. This is the same formula that we've been doing on the check-in for days and days. But it's not the same type of thing. I mean, it's the same, it is an inverse square still, but it's not doing an inverse square style because it's asking how far apart are they. Normally it's like, okay, we just cut the distance in half. What's the force now? And you're supposed to say, okay, we cut it in half, so it says d squared down here. That means the force gets multiplied by 4 when the distance gets cut in half, because that's what inverse square means. But it's not asking about the force this time. It's asking how far apart are they. So we actually have to do the math. So it gives us two charges of negative 1.6 times 10 to the negative 19. So that's the first charge. And that's the second charge. And experience a force of 5 newtons. That's the force of repelling them. Oh, they're repelling because they're both negative. There you go. How far apart are they? Looking for distance. Whew. Okay. Well, I got my formula right there. I'm gonna plug all this stuff in. We got 5 newtons. And oh, the K, we didn't write it down, but they wrote it down for us. K equals 8.99 times 10 to the 9. Don't forget your little shortcuts here. You say 8.99 E9. It makes it a lot easier to type in the calculator, and yeah, it makes it easier because it doesn't need as many parentheses. It's crazy parentheses if you do like times 10 to the 9. All right, what's next? Oh, Q's. Negative 1.6 times 10 to the negative 19. And the other Q is also negative 1.6 times 10 to the negative 19. Ooh! So the internet is not working. The internet's not working? Well, my camera's working. Hopefully the people at home, the internet's working. Is your internet working? I assume if they can see me then.
Hi, camera.
Oh, you can't. Don't come over here, then I have to throw it away because it's illegal.
Over there. I just want to say hi to the people at home.
Okay. If you heard me, you said hi. Well.
Mr. Franklin, you should sing to the people.
No, hold on. We're writing on the next step. Looking for distance. So I gotta write d, and it says squared, so I gotta write the squared. Whew. Well, I remember from before what this times this is, and that times that is equal to, and that's still divided by d squared. However, we don't like it when the d squared is in the bottom right there. Whenever you're looking for something on the bottom that makes it real difficult, you want to get it out of there and then look for it. So it says divided by d squared. I'm getting it out of there by multiplying both sides by d squared. Pew. 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 All right, here we go. So now I've got 5 newtons times d squared equals 2.3 times 10 to the negative 8. Let's see if I can get my calculator to, yeah, okay. Well, that, we wanted to say d squared equals, I guess over here or something, we wanted to say d squared equals. It says d squared times 5. So I'm going to divide both sides by 5. Oh man, one on top, one on bottom. Now it says d squared equals whatever this is, and that's 4.6 times 10 to the negative 29. That's d squared. We're not done yet. We got to get that down to just d for distance. And if I do, let's see, to get from d squared to d, I got to do square root of d squared is d, and that means I got to do square root of this 4.6 business. 6.8 times 10 to the negative 15, and that's the distance, so it's in meters. And there you go. There's a question like this on the CTBAs. Make sure you're doing this with me each time, so that no problem.
Nice.
Cool. Dope dope.
Don't erase it.
What's next? Uh-oh. No, that's got the. I want to pull this over here. Didn't I? Yeah. All right. Freeze. So today.
Sir, my internet's not loading and it's not allowing me to.
Yeah, we'll deal with that in a minute. Let me finish the video first. So we're going to make a chart like this. It tells you in what order to do each thing. It's a little confusing, but I've got, if you look on your instructions, everybody, I'm talking to you too, not just them. If you look on your instructions on there, it's got a text version of this. It's like, oh, okay, first you find the total resistance, and then you find the missing total, and then you find the one that's the same everywhere. And so I'll explain what that means. So here we go. Let's do this one right here. Let's assume that it told us that the total voltage here, it was 14 volts. So I'll make a chart. Chart. So we got V and I and R here. That's the 1, that's the 2, that's the 3. And down here are my totals. So what this 1, 2, and 3 means is like this is position 1, this is position 2, and this is position 3. So the resistance on position 1 is 2 ohms. And the resistance on position 2 is 5 ohms. That's a 5. And the resistance on position 3 is 7 ohms. And the other thing it tells us is the voltage supply is 14, so that's the total voltage. Okay. That's all it tells us. So now we got to start doing the thing. So the first thing to do, find which column you can find the total of. And in this case, it's resistance. On all your problems today, it'll be resistance. So find the total resistance first, because that's what it gives you. 2 plus 5 plus 7 is 14 ohms. And next, the next thing that we can find is this missing total. We can say V equals, V equals I times R, right there. And so we plug in 14 for V, we solve for I, and plug in 14 for R, there. That's a 4.
So do 1.
Yeah, 1 times 14 is 14, pretty sure. So here we go, 1 amp. So that's the first 2 steps. First, find the total that you can find. Then, find the missing total using V equals IR. Next is the easiest step that you don't have to do any math for. Look at the kind of circuit this is, again, to remind yourself. It's a series circuit. Go find the rules for that type of circuit. So for series, up here, okay, I found it. Next, find the thing that's the same everywhere in the circuit. So in this case, that's current is the same anywhere in the series circuit. So then, take the total for that one and write it in all the boxes. So if the total is 1, because current's the same anywhere in the series circuit, it's 1 everywhere. And I know like 1 plus 1 plus 1 is not 3. Or sorry, it's 1 plus 1 plus 1 is 3, but 1 plus 1 plus 1 is not 1 there. I said it right. But whenever it does this same anywhere thing, it's not a real total. The other ones will be real totals, but when it's the same anywhere, it's not going to be a real total and it's not going to work. So it's fine. Like the total thing's not going to work, though. The table will work.
How would it work with the parallel?
In a parallel circuit,
Yeah.
like if you're doing this one,
So it would just be in voltage?
yeah, it says voltage is the same anywhere, so you take that 14 and it'd be here and here and here. But we're not doing that because this is a series circuit. We got to do currents the same everywhere, so we did the 1 everywhere. Last step. You got to figure out these missing boxes with V equals IR using each row. So if I'm using V equals IR here, equals V equals I times R. So I do 1 times 2 is 2. That's V, so it's the volts. 1 times 5 is 5. Josiah, what's 1 times 7?
7.
Good, it's 7. Good. So these tables can be a useful organizational tool to make these circuits a little easier. So today it's going to ask you to find a couple of total resistances to make sure you remember, and then it's going to have you fill out a table for one of these parallel circuits and one of these series circuits. So please go get started on that. Series versus parallel. Today, Wednesday. if you didn't finish the thing from yesterday, this one's more important, so do this one first.
Mr. Franklin.
Hold on, turn off the camera.